Example number 2. A luggage lock opens with the correct 3-digit code. Each wheel rotates through the digits 0 through 9. So the question is, how many different 3-digit codes are possible? Suppose each digit can be used only once in a code. So how many different codes are possible when repetition is not allowed? This is a common theme in these kind of questions, talking about when repetition is allowed and when repetition is not allowed. This is going to come up a lot. So for you to feel very comfortable with this idea will be beneficial to you. So what I could do is I could draw out a diagram like we did for this one right here, but you'll see very quickly that it becomes very cumbersome. So the first digit, the second digit, and the third digit. Now I'm going to erase this, but so you don't have to write this down, but if the first digit is 0, the second one can be 0, and then this third one can be 0, because repetition is allowed. But you can also go 0, 0, 1, 0, 0, 2, 0, 0, 3, 0, 0, 4, 0, 0, 5, 0, 0, 6, 0, 0, 7, 0, 0, 8, 0, 0, 9. You can also go 0, 1, 0, 0, 1, 1. Do you see what I'm doing here? Just from 0, just from the number 0 alone, we're going to have quite a few options. So if we were to do this for every single number, not just 0, but like 0, and then 1, and then 2, and then 3, all the way up to 9, we're going to be here for, I would say, about 3.75 hours. So I'm going to show you, I'm going to remind you of the fundamental counting principle and show you kind of a little bit of a quicker way. So for A, how many 3-digit codes are possible? We have 3-digit code. This is the first number, and the second number, and the third number. Fundamental counting principle states that we multiply these options together. And for the first option, when repetition is allowed, we have digits 0 through 9. So we can use 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Let's just count it. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Whew, there are 10 digits because we count 0 as a digit. So 10 times 10 times 10. So that means when repetition is allowed, we have 1,000 codes possible. However, suppose each digit can only be used once. So we're still going to have a 3-digit code, the first, the second, and the third. We're going to multiply these together. But for the first number, think about it. You can use any number you want. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. But then, after that, say you use 1. Okay? Let's say you use 1 for the first number. How many digits are available to you after that? 1, 2, 3, 4, 5, 6, 7, 8, 9. We all of a sudden have 1 digit that's not available to us. So 9 digits are available. And say that second digit would be 0. Well, how many numbers would be left, or how many digits would be left for the third? 1, 2, 3, 4, 5, 6, 7, 8. So every time one of the numbers is used, we cannot use it again, because repetition is not allowed. When we go 10 times 9 times 8, we get 720 codes possible with no repetition. So you can see when we draw out pictures, like in the first video, it makes it very, very clear. However, when our numbers get a little bit bigger, using a method like this, relying heavily on the fundamental counting principle, it's just going to be a lot, make the questions a lot more doable.